Hello, welcome to this tutorial. Today we are going to create a motor sequence learning task on PsychoPy. What is a motor sequence learning task? You have a sequence of an object coming on a particular location, and that location is mapped to a specific key on the keyboard, and if there is a sequence or predictable pattern in the manner in which this stimulus is appearing on these locations, then your reaction times are going to get faster because you learn the implicit sequence or implicit regularity in the presentation of the stimulus. Now let me show you how it works. So you have 4 lines. Okay, let's call this the line 1 or line A, B, C and D. Okay, now each of these lines are spatially mapped to a particular location on your keyboard. So this A or line 1 is mapped to Z key, and line 2 is mapped to X key, line 3 to C and line 4 to V. So Z, X, C and V, they are spatially next to each other on the keyboard. Similarly, you are mapping each of those lines to each of this keyboard, and the task is to press the corresponding key when a triangle comes on top of a specific line. For example, in this case, the triangle is on top of the line 2, so you have to press X key. Okay, so if it was here, the correct response would have been Z, and if it was here on line 3, the correct response would have been C, and if it was here, the correct response would have been B. Okay, so that is the task. Now let me do a couple more trials to kind of demonstrate this. So I'm pressing X here. Okay, and in this trial, the correct response is going to be Z. Okay, and in this trial, it's going to be C. Okay, now there is going to be an implicit pattern of or implicit sequence here. So one potential sequence could be the triangle on one trial could be here, on the next trial it will move here, and the next trial it move here and then to here, and this pattern can repeat, and participants will acquire this pattern, and that will make their reaction time faster as they continue doing this task. So this is the standard motor sequence learning effect. And also there is a potential for a general practice effect, right? So participants could also get better at doing a task without really learning the sequence. So in a control condition where the sequence or the order in which the triangle is going to appear on each of these lines is going to be completely random. So if there is a difference between the sequence condition versus a random condition, that is going to be because the participants could learn the implicit regularity in the implicit regularity in the sequence. Okay, now let's try to build this on PsychoPy. All right, so we have a blank PsychoPy window here. Firstly, let's create a fixation. For 1 second. Okay, make it across, layout, change to spatial unit pixels. This will be a 10 by 10 fixation that's going to come and stay on the screen for 1 second. Okay, so that we have that. Now let's add all the 4 lines. Okay, let's change to 1 second so that line starts a line appear on the screen after 1 second, or basically after the fixation is stayed there for a second. And this is going to be a rectangle, not a line. You can also use the line function, but a thin rectangle is going to look like a line. Okay, so what's the position? Spatial unit is going to be pixels. Now orientation should be 90 degree because by default it is a horizontal object that is shown on PsychoPy, so you have to move it to the vertical position by rotating it 90 degrees. What is going to be the size? It is going to be 100 by 10. So 100 pixels in terms of the length and 10 pixels in terms of width. Now this could be a little counterintuitive the way it's written here. So it is it's basically the opposite. So you are not giving the width here, basically giving the height here, because you are showing it in a vertical orientation. So make sure that you don't confuse that. Now position. Okay, now what's the position going to be? There are 4 positions. Let's now let's create the first line on the leftmost side. Leftmost side would be on the minus side. Okay, so let's go for 150 pixels to the left of the screen, okay, in x-axis. Now for these lines, since we are stacking up each of these lines next to each other, we are only changing the x-axis positions. The y-axis, we are not making any change. So let's sort of keep it constant at 60. We'll only change this value moving ahead. So we have that appearance, everything. Let's go for the defaults. Okay. So now we have the polygon here. Sorry. So here on the x-axis, if you go for 60, it is going to be slightly. Sorry, on the y-axis, if you go for 60, it's going to be slightly above the center of the screen. If you want exactly at the center, go for 0. So that will be the better option. Okay. Now we have the polygon 1 here. Let's call this the line 1. Okay. This is going to be our first line. Okay. Now all you need to do is copy this and paste it and call this the line 2. And do that 4 times. Line 3 and line 4. All right. So now we have 4 lines, and there's only one parameter that you need to change, which is the position. Here, let's change this to from 150. Now this time, let's shift the second line 100 pixels to the right. So minus 150 plus 100 is minus 50. Okay. Now again we'll draw the next line on the right side of the fixation. So that's the only thing that you will basically change when you copy paste these lines or these components here. So this is the third line. Third line is going to be 50 pixels to the right of the center. So that is going to be positive 50 or plus 50 here. And line 4 is going to be plus 150. So we have now 4 lines, minus 150 pixels, minus 50, plus 50, and plus 150. So 4 lines are there now. Now let's add the triangle. Okay, so triangle should come on top of one of the lines. Okay, now let's call this the probe. Okay, now what's going to be the duration? We want the lines to stay there for some time, so let the line stay there for 1 second before the triangle come on top of that. So duration again 0 until response. Shape is going to be a triangle. Okay, now what's the position of the triangle? Okay, so on the x-axis, this is going to be a variable because we want them to be appearing in any of the 4 lines. Okay, and the y-axis, it is going to be constant, but it's not going to be 0. We don't want the triangle to be appearing on the center of the line or center of that little rectangle that we are drawing. We want it to be on top of that. Okay, so let's think about it. What is the kind of length of the rectangle in the vertical axis? It's 100 pixels, right? So if you're anchoring in the center, we need to jump at least 50 pixels in the positive direction so that the triangle will come on top of the line. So let's jump. Let's for the to be safe, let's jump 60 pixels on the vertical axis so that the triangle appears on top of the lines. Okay, so I need to change this to pixels, and this will be a 10 by 10 triangle. So this is going to be a prop. So there's only one sort of variable here which we need to define. We'll define that using the Excel file that we are going to upload to later. So that's going to be there, and now let's set this to every repeat. That's what we always do when there is a variable that is defined. Okay, so now we have the probe here. We need a response, right? So we need a keyboard response. Okay, now keyboard response, when does it start? It can start the moment the probe appears, which is 2 seconds, and it's until there is a key press, it should be there. So let's keep the allowed keys blank for now, but ideally you would want Z, X, C and V to be added here, but if you keep it blank, it will just take all responses. Now we need to store a correct response. So let's create a variable correct response. We will again define this in the Excel file. Okay, so now we have the key response, the triangle probe, all the 4 lines, and the fixation. Okay, now let's go to open Excel and create our conditions. What are the 2 conditions? We have the position as a condition and correct response as a condition. All right. So what are our 4 positions? We have minus 150, minus 50, plus 50, plus 150. Now we don't want it to be in a sequential order, right? Although we are keeping the sequence constant, we want it to be in a specific order, something like A, C, D, B, for example. So let's sort of create a random sequence here. Let's start with minus 50 and then 150, then plus 50 and then minus 150. That's sort of a not so serial sequence. So what's going to be our correct response for minus 50? Remember, minus 50 is the second item from the left, which is on your keyboard. The key is X. Okay, 150 is going to be the last item to the right, which is going to be the V key, and 50 is going to be the one to the left of the rightmost item, which is C, and 150 is the leftmost line, which is Z or Z. Okay, so now we have all the positions and corresponding key press. Okay, now let's save this. Okay, let's call this sequence conditions. Okay, and make sure that you save this as a CSV file. Okay, cool. Now we have that saved. Now let's go back to PsychoPy. Here we need to add a loop as always. Okay, now in the loop you specify the conditions file, which is going to be the sequence condition here. Okay, now we have the sequence condition file added. We can see 4 conditions across 2 parameter POS, position and correct response here. Now we don't want the loop type to be sequential. We want it to be we don't want it to be random. We want it to be sequential, because that's the idea, right? The sequence should repeat. Okay, now you can specify the end reps, and if you let's say have 12 repetitions, there is going to be 48 trials in this loop. Okay, so yeah, let's keep it at 12. All good. Now we have the loop here. All right. Now what we also need one more control condition. Remember, so we have a condition where there is no sequence at all, right? So that's going to be our second routine. Now let's insert that routine. Now there is an easy way. You can basically duplicate an existing routine. So you just need, go to insert routine, and it will ask you whether you need a new one or you just need to insert an existing one. So the downside of that is that you cannot have a separate name for the routine, so it won't come up in your data file. So you should know what sequence you had. That's the downside. So ideally you would want to create a new one and basically to repeat all of this, but let's just go for the easy option. So we've added the try loop. So now we can see that both these routines look the same. Now I need to insert a loop in here as well and change the n reps to 12. This time, instead of sequential, we need to go full random. Okay, and the conditions file is going to be the same file that we created. Okay, so we can see the positions and correct response here, and make sure that this checkbox of each trials is checked. So we have now two routines. This first routine here is the sequential routine, and the second routine is going to be full random. Okay, now we have both of them. Okay, now we are good to go. So here I mentioned 12 reps. So I just want to show a demo. So I'm going to change it to 1, and also on the second random loop, I'm going to give the n rep, change the n rep to 1, so that this is for demonstration. And also, since I just copied these routines, it's difficult to know which routine is going to be, which routine am I in. So just to make sure that while I demonstrate it, you understand, I'm going to change this color of the sequential routine to blue, so that we just know whether it's a sequential block or a random block. In reality, you won't do that. You don't want to give your participant any information on whether your condition is a sequential or a random condition. So we are good. So now let's run this and see how it looks. So you should expect the sequential 4 trials in the beginning, and then the random 4 trials in the last 4 after that. Okay, now I press X, I press V, okay, I press C, and I press Z. So that was a sequence. Now it's going to be the random ones. It's V, and then this one, and then this one. Okay, cool. Now that was the little quick demo, and you can also see that when I changed the color of the fixation in this, the color of the fixation sort of copied itself to the next one. So that is because instead of inserting a new routine, that is the ideal method. This is just for the sake of doing it faster. I just inserted a copy of the first routine, and just changed only one setting here. Changing this loop to random and this to sequential. But ideally, you would want to create a new routine. So just a reminder there. Now I have data of a task which I performed on myself. This is the same task that I just showed you, and this has 96 trials, 48 sequential and 48 random. So let me just clean up this so that we are just looking at the reaction time. Okay, now let's just look at the reaction time. I'm going to remove this and remove these ones as well. So we just need the reaction time for now. So we have the key response RT, key response correct, which basically tells you whether the key press was right. You can see I made a couple of mistakes here, one more here. 4 mistakes. We'll remove those trials later. Firstly, let's categorize these trials into sequential versus random. So the first 48 ones were where sequential. So let me copy this and paste it here and call it sequential RT. Okay, so we have that. Now the remaining 48, I'm gonna change it. I'm gonna copy it and paste it here. Right, we have the 48. I did not remove the inaccurate trials, but whenever you're calculating anything on reaction time, it's very important that you remove all the inaccurate trials. We just had 4, so I'm just letting it be. Okay, so now we have the sequential reaction times and the random reaction times. So this is where there was a sequence, this is where there was no sequence. Now let's go ahead and plot this. Let's insert a line graph. Okay, and right click, select data, and this is going to be our data. Okay, now let's add legend so that we know what's here. Okay, now you have the sequential RT blue and random RT in sort of orange color. Now this is not ideal data because it's again 48 trials each. You would ideally want more number of trials for this effect to sort of show up. And you would see that if participants are learning the sequence, then the RTs will fall faster, or the RTs will get faster in that condition as compared to the random sequence condition. Okay, so this is the demo for motor sequence learning task, very minimal one. All right, thank you.